Welcome to Geometry Pre-AP, the greatest course in the world. Today we're going to talk about similar solids. Before this lesson, we've talked about similar polygons and perimeter and side lengths and how those ratios compare. And then when we did area, we talked about how figures that are similar have side ratios, perimeter ratios, and then area ratios. And now we're finally moving into three-dimensional solids. So at the beginning of this lesson, we're going to do a little exploration before we go into the theorems that we're going to be using. So this first little question, we have a few questions here. You can pause the video if you'd like and answer these questions, and then start the video back up again, or you can kind of follow along with me as this video goes. All right, so the first thing I want to do is says compare the ratio of the sides. So if I take two sides, let's call this small and big, and I'm going to do a ratio of small over big, and that would be 3 to 9, which is equal to 1/3. So my ratio there is 1 to 3. If we were to do the perimeters of the figure, the perimeter of this figure here would be 8 times 2, which is 16. And the perimeter of this figure right here would be 24 times 2, which is 48. And so if we did a ratio of the perimeters, that'd be 16 over 48, which is also reduces down to 1 over 3. And we should know this because we did this back in a unit in first semester in chapter 6, and we also did it again when we talked about polygons and similar polygons. Now if we do the ratio of the areas, the area for this figure here is 15, and the area for this figure right here would be 135. 9 times 15. So if we do a ratio for the areas, I'm going to bring this question down over here, then that'd be 15 to 135. I'm still doing that small over big, and that would reduce to 1 over 9. All right, so if we look at this, it says, what can we conclude from comparing the ratio of the sides, the perimeters, and the areas? So if you look at it, the side ratio is 1 over 3. The perimeter ratio is 1 over 3, but the area ratio is different. That's 1 over 9. And if you remember back to what we did first semester, what we ended up finding out is really this ratio is 1 squared over 3 squared, because the ratio of the areas is the square of the side of the perimeter ratio. So side and perimeters measure are length measurements, and they're the same type of length measurements, so they have the same ratio. But area is in units squared, so the ratio is squared. So that's just a little remediation of something we did. Now, we're going into a solid. Now at this point I haven't taught you surface areas, so you may not be able to find the surface area of this figure, but if you want to pause it and make an attempt to try to find surface area, remember I've already taught you all the formulas, you can, and then come back to the questions. Or you can just follow along with me. So I kind of pre-did some of this work for us, and so when we look here, the ratio for the sides, that should be easy. We can just compare two corresponding sides. And so let's do, we got big and we got little, so let's do big over little. It's nice to always have a ratio. And so our big here is like, say, 18 over 6, but that reduces to 3 over 1. So that's a ratio for our sides. Now, if you remember in the last slide we just did, we talked about the ratios for the areas. Now this says surface area. Surface area is different than area because area is a 2-dimension and surface area is a 3-dimensional. But they both are measured in the same units. And if I actually go and find the surface area of this figure, the surface area for this figure is 648, and the surface area for this figure is 72. And you could get that by finding the area of each rectangle of all 6 sides or faces and adding them together. You get 648 and do the same thing for the little one. So when I write these ratio, big over little, that's 648 over 72. And when I simplify that ratio, I get 9 over 1, which is the same thing as 3 squared over 1 squared. Because remember, it's units squared, and so it's the ratio for the sides or perimeter squared. Now volume. We should be able to find the volume here. And so the volume for this big figure is 18 times 6 times 9. So the volume here is 972 units, and the volume here is just 36 units. So when I compare the volumes, 972 over 36, and I simplify this ratio, that's not 1 over. That is 27 over 1. Now remember, first semester we also made you work on memorizing all of the perfect squares and the cubes. So this number should look familiar. Remember, volume is measured in cubic units. So what I can now do is I can rewrite this ratio as 1 to the 3rd power all over 3 to the third power. And 3 to the third power is 3 times 3, which is 9, times another 3, which is 27. Units cubed, ratio cubed. Okay, so every time you do a similarity question, I want to see your side ratio, which in this case is 3 to 1. I want to see your surface area ratio, which is going to be 9 to 1. And I want to see your volume ratio, which is going to be 27 to 1. And you could even write this as 3 squared over 1 squared and 3 cubed over 1 cubed. But I want to see this every time you work a similarity problem, because you need to be looking at all three ratios and asking yourself, which one do I need to use to solve the problem? So that brings us to theorem 12.13. It says, if two similar solids have a scale factor of a to b, their corresponding areas have a ratio of a squared to b squared, and their corresponding volumes have a ratio of a cubed to b cubed. Remember, the area could be surface area, lateral area, base area. Any of those things are all areas, so they still have that same ratio, a squared to b squared. All right, so here we have a few questions. It says, in the exercise, it says, solid 1 is similar to solid 2, so knowing that they're similar helps. And it says, what is the scale factor? So volume is in cubic units. So if I look at this volume ratio, this is 8 pi over 125 pi. Now the pi's cancel, so I'm left with 8 over 25. Now volume is cubic units, and I want the scale factor, which is just units. So something new that we haven't done before is we're going to take 8 over 125. We're not going to take the square root. We're going to take the cube root. You can find that on your graphing calculator under the math key. You'll see a thing that says cubed root. So when you take the cube root, again, if you know your cubes from back in first semester, you would know that 2 to the third power is 8, so this is 2. And 125 is 5 to the third power, which is 2 to 5. So the ratio here is 2 to 5. Okay, so you do this one right here and compare those. All right, now this one, notice the ratio is different. It says S. This S stands for surface area. So if I look at my surface area ratio, it is 288 over 128. Now, earlier I had 8 over 125. That couldn't be reduced as a fraction, but 288, that can be reduced. That's the same thing as 9 over 4. Now, if I'm going to find my side ratio, remember this is surface area, so that's the squared ratio. My side ratio is going to be the square root of this one, which will be 3 over 2. Remember that if you simplify those ratios before you try to square them or cube root them, they sometimes will be so much easier to see. But if you don't simplify them, you're going to get radicals and other weird numbers in there that may confuse you. So do number 15 here as a practice, just like the one I just did before this. Now, I'm not giving you the answers for those two I asked you to do, because you should be able to apply these concepts to those two. If you had a problem, you can ask when you come to class. All right, so a little more work here. So if the ratio for two solids lengths are 1 to 5, now it doesn't tell us what the solids look like. It doesn't tell us what that length represents. It's just saying the ratio for these two similar solids is 1 to 5. What would the ratio for the surface area be? Well, if this is for sides, then all I have to do is say 1 squared to 5 squared, which would equal 1 to 25. What would the ratio be for volume? Well, that's the side ratio cubed. So that would be 1 to 125. So those are my two ratios. So I now have three ratios. I have 1 to 5, I've got 1 to 25, and 1 to 125. So it says if the smaller solid has a volume of 34 inches cubed. So let's do small over big to get our ratio set up. So volume, which ratio is volume? 1 over 125 equals, it says the smaller solid, so remember we're doing small over big, so 34 goes on top, X goes on the bottom because that's the larger one. I don't need to know the dimensions. I don't need to know how to find the volume of this figure. I just know they're similar, and so then I can cross multiply and solve. When I solve for this, I get 4,250 inches cubed because I'm talking about volume. And that's how I find the volume of the similar figures, by knowing the volume of the first figure. So rather than doing the volume formula twice, I only had to do it once to know what this first figure was, which they gave me, which was nice. And then I can set up a proportion and find the other missing volume. Okay, so here's a different question. It says, if two solids have a ratio for the surface area of 16 to 149, then answer the following questions. So pause the video, take a minute to do these questions, and then turn the video back on, and I'll actually put the answers up here for you. All right, so this is surface area, and it's 16 to 49. So side lengths, if that's units squared, I got to square root that, and that gives me 4 to 7. Now volume, I can't use surface area to get to volume. If you mistakenly do that, you're going to have a lot of problems. We got to use the side ratio. So that's 4 to the third power and 7 to the third power. If you're ever given surface area or volume ratios, the first thing you need to do is go find that side ratio first, because you really don't know how those ratios compare until you have that ratio first. And so 4 to the third power is going to give us 64 to 343. Okay, this is why we asked you guys to learn those cubes first semester. So it says if the similar solids had a side length of 12 inches, so side length, which ratio am I going to use? I'm going to use the side ratio, 4 to 7. And it said the smaller is 12. So here's my smaller one on top because I'm doing small over big still. My unknown is in the bottom. Cross multiply, 4x equals 7 times 12. Divide by 4. Those cancel to be a 3, and I know x is equal to 21 inches. And that's my unknown value for my larger figure. Okay, we don't know what kind of figure it is. We just know it's a solid. What kind of figure it is doesn't really matter in this case. Okay, now since we haven't talked about surface area, I'm going to give you the surface area for figure number 1. If you want to practice your little surface area early, you could go and find the surface area of that figure. You'll be doing shapes like that when it comes down to the next unit. But the volume for figure 1, you can do. So take a minute, pause the video, and go find the volume of figure 1. Okay, so you should have found the volume from figure 1. And so the volume there should have been 20 pi. And of course, that would be feet cubed. You should have used 1/3 pi r squared h plus pi r squared h. Okay, and so that was 1/3 pi times 2 squared times 3 plus pi 2 squared, and the height of the cylinder is 4, and that's how you get to 20 pi. So, yep, that all looks right. All right, so what are the ratio for the sides of these two figures? Well, if you want to pause this video now and try to work this problem and then turn it back on and watch me finish this problem, that would probably be a good way to see, do you understand what's going on or not? If you're not sure, watch it and see what happens. So the side ratio here is 4 to 8, but that can be simplified. That's 1 to 2. So remember what I said, every time you do a similarity question, you have all three ratios. So what would the surface area ratio be? Write that down. Okay, so it should be 1 squared to 2 squared, which is 1 to 4. Now let's get the volume ratio. See if you can do that one real quick. Okay, so the volume ratio is going to be 1 to the third power, 2 to the third power, which is equal to 1 to 8. All right, so we got to find the volume of this large figure. We don't really have enough information to do that, so let's do it the easy way, which is using our ratios. So if we're going to do volume first, I look at the volume ratio, 1 over 8. Okay, this is small over big. So I'm given 1, which is the small, which is 20 pi. The larger goes here. I cross multiply, and I get x is equal to 160 pi feet cubed. And that's my volume. I didn't have to go do the whole entire formula. I was just able to use a similarity. Now, surface area. Go look. Surface area ratio is 1 to 4. The smaller one's 20 pi plus 2 pi squared root of 13. All over my unknown, I'll just use letter y here in this case. Cross multiply, so y is going to equal, distribute the 4. 80 pi plus 8 pi squared root of 13. Of course, this is going to be feet squared because it's surface area. And there you have it. That is your answers for your surface area and your volume of the unknown figure. You're going to have some problems like this in your homework, so make sure you pay close attention to those figures. All right, so finding surface area Another question, it says two cylinders have a scale factor 2 to 3. Find the smaller cylinder has a surface area of 78 pi. Find the surface area of the larger one. Okay, so I want you to try these two problems here. Do this one also. Pause the video, turn the video back on when you're ready to do it, to see the answers. Okay, so I'm probably going to check the notes on this today. So just reminding you, I'm going to check the notes. I'm going to ask to see your notes, and I'm going to want to see work for this problem. So the answer for the first one should be 175.5 pi meters squared because it's surface area. And this next one says find the surface area. Should it have 1 to 4? Okay, remember it did say smaller to larger there. All right. So, big question here. Good question here. You're going to want to do this one. There's a bunch of this. This is like the challenge practice I've had on many worksheets before, and I always put these on the test. So be ready for these. So they give us surface area. So that's 266 pi to 2,394 pi, and that's surface area. So the first thing we have to do is simplify. Okay, and so when we simplify that, we get this to be 1 over 9. So remember I told you you need all three ratios. So if the surface area is this, what would the side ratio be? It would be 1 over 3. What would the volume ratio be? Well, that would be 1 to the third power over 3 to the third power, which is 1 to 27. So I have all three ratios. What is this question asking us to find? This question is asking us to find the missing value for x, and x in here represents, this equation right here, represents a side length. So sides use the side ratio. So I have 1 over 3 equals x minus 2 over 2x plus 3. Remember to keep your figures in the same ratio that you did in the very beginning. So if I cross multiply, I get 3x minus 6 equals 2x plus 3. And I subtract the 2x from each side, so minus 2x minus 2x. I get x minus 6 equals 3, plus 6, and plus 6. So x is equal to 9. That is the value of x that would represent, that would help me finish off these similar solids. Okay. And that is our last slide. These examples are used throughout your homework, so make sure you have these so that you can compare and look at them when you're practicing your work. I will make sure you ask me to give you the surface areas for the problems that are like this right here so that you don't have to find the surface area yet, that you can do that on our next unit test. Have a good night and have a good weekend.